this video we'll cover the last two sections in cycle 3. So 3.9 is solving what we call nonlinear equations. And by nonlinear equations, we mean equations of this type. So they've got, this one for instance has a square in it. So how would you solve this problem? Remember, reversing the operation, we'll take the square root of both sides, so t could be either plus or minus 20. On this problem here, the first thing we want to do is divide both sides by 4. So then we have t squared equals 100, and then take the square root, so we get t equals plus or minus 9. This problem has a square root in it, so in order to solve it, we're going to have to reverse the operation and square both sides, so y is 81. Same thing on this one. First we want to square both sides, and so then we get 3y equals 81. Then we're going to divide by 3, and we get 27. And on this problem here, this is like a proportion we could cross multiply, and we're going to end up with x equals 1/8. And likewise on this one we can cross multiply, and we'll get 8 equals 16x rather equals 1, and so x is equal to 1 over 16. And we're also going to go in this section to solve an equation for a variable. So for instance, this equation gives time, t, needed to travel 300 miles based on the rate or the speed of the car. So this is an example of a rational function with a variable in the denominator. What speed is required for a 300-mile trip to drive 4 hours? So what we're going to do is put 4 in for t, and then we want to solve for the rate. So notice the variable we want to isolate is in the denominator. One way to be multiply both sides by r to get the variable out of the denominator, and then divide by 4, and we come up with a rate of 75. So the required speed is 75 miles per hour. Here's another rational equation. On this one, again, we can solve it as a proportion and cross multiply. The other thing we can notice is that this is a ratio that equals 1, so that means the numerator must equal the denominator, and in that case x would have to equal 56. And then the last section, again, is more rewriting of formulas. So sometimes we need a formula in a different form that is presented to us. For example, if we wanted to know the area of a circle as a function of its radius, then the formula is in the right form. But what if we wanted to know instead the radius as a function of the area? Then we'd have to solve this equation for r. So these two formulas describe the same relationship between the radius and the area, but the form desired depends on the question that you're trying to answer. And in this section we'll focus on rewriting a formula for a specified variable. And here's the box that explains that in your textbook on page 383. So let's try a couple of examples. So here we have distance equals rate times time, and we want to solve for t, so we're going to divide both sides by r, and we get time is equal to distance divided by the rate. Solve this equation for r. The first thing we're going to do is subtract p from both sides, and then we're going to divide by pt, and so come up with this. The rate r equals a minus p divided by pt. This one we want to solve this for, I didn't tell you which variable, it should be solved for r. So the first thing we're going to do on the last formula is divide both sides by 4 pi and then take the square root. So the radius is equal to the square root of the surface area, this is surface area, divided by 4 pi. Find the slope and the y-intercept of this equation. So it would help us to put this equation in slope-intercept form. Y equals mx plus b, and in that case what we're going to do is solve this equation for y. So the first thing I'm going to do is subtract 4x from both sides, and then the next thing I'm going to do is divide through by -3, and I want to isolate the y by dividing by -3, and I come up with this equation. And so now I can tell the slope is 4/3 and the y-intercept is 0, -4. And here's another equation. Solve the equation for y, identify the slope and the y-intercept, and then use those to graph the equation. Alright, so if I solve this for y, I don't show all the steps here, but I'm going to come out with y equals -2x plus 5. That tells me that the slope is -2 and the y-intercept is 0,3. And then I can go ahead and graph that. I can graph the y-intercept at 0,5, and then I can use the slope of -2 to go ahead and say -2, so down 2 over 1, down 2 over 1, so I can find additional points on the line. We've learned how to use the slope form, y equals mx plus b, to write the equation of a line. Let's consider another method for finding the equation. We begin by writing a version of the slope formula you saw in section 3.3, but replacing it with a generic point, with one of the specified points, rather, x2 and y2. And we call this the point slope formula. So y minus y1 equals m times x minus x1. So substitute a specific point for x1 and y1 and then this value of 3, and then you can come up with the equation of the line. So this is another important line formula to use, the point-slope formula. So we have this y-intercept and then we have the point-slope formula because it uses one point and the slope in order for you to find the equation of the line.